All right, folks, so here's a recap on today's lesson. So if you have an outside function with an inside function, what we learned yesterday is that if you take a derivative of that outside function with an inside function, is going to equal to derivative of the outside times derivative of the inside, okay? And that is basically what this says here. So this is a function notation of an outside function with an inside function. And this means derivative of outside, and this means derivative of inside, okay? By the way, if you see f little og of x right here, this means basically this, which is the same as this right here. Okay, whoops, which is the same as this right here. Okay, so f little og of x. Okay, this apostrophe should not be there. Okay, so this should not be there. Okay, X that out. Okay, now, so let's use that in practice here. Okay, so when you do these problems, the first thing you're going to want to do is set up the general form. Okay, so again, this is derivative of outside, and then this is derivative of inside. Okay, so derivative outside times derivative inside, I'm going to copy that down. Okay, now it's asking for, so now what it's saying is that find h prime of 3. That means anywhere you see an x, you put a 3. So that's why the red 3's exist. Okay, now, so g of 3, okay, or as I like to call g regular 3 is 4. G prime of 3 is 1/4. Okay. Now we have f prime of 4. Okay. F prime of 4 is 6. Okay. 6 times 1/4 is 3/2. Okay. Now, here we go. Quotient rule. Okay, this is quotient rule with the chain rule. So we have a function divided by function, which is already clues us in that it's going to be quotient rule. So low d high minus high d low. Okay, and then because this is not just a g prime of a clean x, this is a 2x, that means there's an inside function of 2x, which means we have to do derivative of inside once again, which is 2. Okay, and now we just plug in for the x. Anywhere you see an x, you put a 1, hence the red 1's here. Okay, and now let's just clean up some things. This is a big 2. This is a big 2. Now let's just plug away. G regular of 2. G regular of 2 is 4. Okay. F prime of 1 is 1/2. Excuse me. Is -3. Okay. F regular of 1 is going to be 2. G prime of 2 is 2. And over here, the 2 just got carried down. You just simplify and get -5/4. Okay? Next example, folks. So far, I like to think of what we've done so far is we plug in by going on a scavenger hunt with the table to find the values to plug in for. Now we're going to go on a scavenger hunt through a graph to plug in. Okay? So again, here is asking us for, we're going to set up with this green, which is that same thing from the first slide. Okay. Right here. Okay, so let me actually copy and paste it. So this top green right here, I literally copy and paste it right here. Now, anywhere you see an X, we're going to put a 3, hence the 3 is right here and here. Okay? Now, G regular of 3, we're going to plug in 3 into here and get 2. So G regular of 3 is 2. G prime of 3, okay, what we're literally going to do is take the derivative of this and get that, and then plug to get G prime. And then we're going to plug in 3 into this and get 3. Okay? So when you plug in 3 into this, you get 3, hence this. Okay? Now, f prime of 2, okay, they don't give us any specific function for f prime, okay, or for f or f prime, but they give us a graph for f. Okay, if you look at the sparkly right here, the sparkly font, this is the graph of f of x. F prime means the slope. So if I were to translate this into English, is asking for the slope at x equals to 2. Okay, the slope at x equals 2, first of all, it's a negative slope because it's downhill. And because it's rise 2, let me use a different color. Because it's rise 2 run 4, okay, 2 over 4 reduces to 1 over 2, and negative because it's downhill, like I said. Okay, so f prime of 2 translates to the slope at 2, which is negative 2/4, which is negative 1/2. Okay, and just simplify. Now, if this said f prime of 1, 2, or 3, 1, 2, or 3, the slope, you get the same answer because the slope in either one of those x values is going to be negative 1/2 or negative 2/4. I should say negative 2/4 or negative 1/2. But if it said f prime of 4, because it runs into the tilting issue, okay, you would get an undefined, which would make the whole thing undefined. Okay? Second to last example, this is basically the chain, this is basically the table, okay? Now you have, it's asking for g prime of 2, okay? So we're given the greens, let's take the derivative of both sides, okay? So literally I copy down the greens here, take the derivative of both sides. The derivative of 8x is 8, and through the chain rule, this green becomes that green, okay? All right, this is literally copied from the first slide right here at the top, whoops, right here I should say, okay? Whoops, right here, okay? All right, so I copy this down right here to right here, all right? Now we're just gonna plug in, this implies, it's asking for g prime of 2, which implies x equals to 2. So anywhere you see an x, you're gonna put a 2, so instead of xx here, we're gonna put a 2, 2. G of 2 is given to us, it's 6, so g of 2 becomes 6. F prime of 6, well, that's given to us, f prime of 6 is negative 4. So this becomes negative 4, okay? Negative 4 times g prime of 2 gives you 8. Divide both sides by negative 4, and we get negative 2, okay? Now, last example over here, the line tangent, automatically when you see line tangent, you should think point slope form, which is this green right here. With point slope form, you get the slope in orange and a point, which is blue and gray. Okay, so let's find the slope. Well, the slope is synonymous with derivative, so we're going to take the derivative. So this becomes this through the chain rule. Okay, all right. And now, let me just explain that a little bit, even though it's repetitive, you guys should know it. Okay, we're going to say the inside function is sine of x. Okay, so we're going to set that equal to u. So the derivative of outside is going to be 5u to the power of 4. Okay, and remember, u is sine of x, so we're going to uncover the u. Okay, to become sine of x. All right, or let's just say 5, let me not even go there. The derivative of u to the power 5 is 5u to the power 4, and let me just leave that as it is. Now, u happens to be sine of x. U is the inside function, which is sine of x. We're going to do derivative inside, which is cosine of x. So we get 5u to the power 4 cosine of x, and then we resubstitute for u. U is sine of x. So that's what we get. Okay, that's chain rule again. Now it's asking a pi over 3, so we plug in pi over 3 for x, and we get this, and use unit circle, and we get root 3 over 2 for sine of pi over 3. We get 1 over 2 for cosine of pi over 3, and we just simplify and get 45 over 32. That goes in for your orange right over here. Okay? Your x sub 1 is pi over 3, that's given. Now, to find y sub 1, we literally plug in, okay, pi over 3 into your original function. Okay? So pi over 3 into your original function gives you this. Sine of pi over 3 is your, okay, done. Just leave it over there. You're good. Thanks, John. Appreciate it. Sine of pi over 3 is root 3 over 2 from your unit circle. Okay? And then this simplifies to that, and we plug that into y sub 1. Okay? Now, so we basically, these three highlights basically become this right here. Okay? And don't forget to add this to both sides. Now, what I was going to say is this. Now, if I graph, okay, if I graph this original function, I get the red graph. Okay, and x equals to pi over 3 is this point right here. Okay, and if it's asking for the line tangent, it's asking for this green line right here. So tangent, the line tangent to the red graph at x equals to pi over 3. So this green line is basically, this green line right here is basically this is the equation of that green line. So when you plug this into Desmos, okay, and also plug in this into Desmos, you're going to get the red and the green. Okay, so all I'm trying to say is that we basically found the equation of this green line. Okay, and that's today's lesson. Thanks for tuning in, folks.